Hi students, up to now we had discussed the chapter called chemical reactions and equations. In this video we are going to discuss about the second chapter of the grade 10 standard, that is called acids, bases and salts, and this is what the chapter that we can connect in your day-to-day life. Let us see what is the meaning of the acid, base and salt before we continue. Okay, but let us recall, did we came across the acids or the bases any time in the previous classes that were passed up, that's in the grade 9 standard or 8th standard? Let us see what are the acids. In a simple way, we can say these acids are sour to taste. What are they? Sour to taste. Have you ever tried by taking a lemon and cutting it half of the piece and squeeze the remaining juice of the lemon on your tongue? What taste do you find? Is it sour or bitter? You may be observing it is sour to taste. Now, never taste any acids that are present in your chemistry lab, because these acids that we are going to speak, they are corrosive. Which acids are highly corrosive? Let us see. The acids are mainly classified into two categories. One is called the acids that are taken from the plants and their products, and the second one is the acids that are in the lab. Those are called mineral acids. So these mineral acids are highly corrosive, so we don't want to taste in the lab. Please don't say the acid is sour by testing it in the lab. We had applied the application by the citric acid that is present in the lemon juice. It is an organic acid. And what else did we learn in our previous classes? We had learned in the chapter number 1, chemical reactions and equations. That is, when we came across the activity 1.2, we came across that zinc granules when reacted with the dilute hydrochloric acid, they formed zinc chloride, and so they released the hydrogen gas. So these are the previous topics that we came across the word acids. So let us see here about the acids that we came across. The acids are sour to taste. We are going to study about some of the properties of acids initially. Then we will go in depth. What is an acid actually? What do it will give? So what is the taste of an acid? Acids are sour to taste. Yes, and they release the hydrogen gas when they react with the metals. Do you know, at your home, while your mother is storing the boiled so-called milk to prepare the curd, she will be taking up any plastic container, but never she will take any copper container, because the curd that is formed in the copper container, if it is left for 2 to 3 days, it will be having a different smell and taste. Do you know why so? The reason is here behind. The copper container we take, it is a metal, and the so-called the acids that are generated when the curd is stored for a few days, the acid is going to react with the copper container, and that releases the hydrogen gas in the so-called container, and that changes the taste and smell of the curd. So why the curd is not preserved in a copper container? Because after 2 to 3 days, the acids that are formed in the so-called curd, they will be reacting with the copper container. Hence the curd is not stored in the copper container. In return, it is stored in a plastic container. So this is the application type question that we come across. Very good. Now what are the remaining properties of the acid? Every acid we cannot taste it. We had already came across the point. Never taste the acids that are present in the chemistry lab. What will happen if you taste the acid? Nothing happens except you lost your tongue, because these acids are highly corrosive. What are they? Highly corrosive. What is meant by the word corrosive? It is the one that which eats up the surface. On whatever the surface it falls, except on the glass, because the acid in the chemistry lab, it is stored in the glass container. It will not eat up that glass, so called. But you can see the symbol that I had used there, giving a number 8. It is a corrosive. Which one is a corrosive? Acid is a highly corrosive. For example, it falls on any person's face. We can observe some of the areas in the old previous days, they used to hurt the women by applying the acid, because these acids are highly corrosive. So never try to place the acid on any person, because they will lose their entire life. So please be here to understand. The acids that we are going to study is to study their property, but not to hurt anyone, because they fall on any skin, so called, they will completely damage up the skin and they'll eat up the flesh, because they have the property called corrosive. And if they fall on any cloth, they will eat up the cloth. And it's the main point. Once you enter into your chemistry lab, you must be very cautious. That is, you must not place your hands on the tables, because if at all any acid particle is left behind on the table by the previous batch, they had completed the experiment, it may hurt your cloth, and finally the acid may be corrosive, that after eating up your cloth that you had worn, it may go on corrosive to your body parts also. So please take care that the chemistry lab acids, they are highly corrosive. So we came to know the third point. What is the third point? The acids are corrosive in nature. Means if they come in contact with any surface, they eat up the surface of the contact that they come in. Okay, good. So we must be very cautious about the acids, especially which kind of acids? The acids that are present in our chemistry lab. Good. Now let us see a few more properties of the acids that we had from our grade 8th standard. Now how can we say that a compound is acid without tasting it? Then we are going to use the litmus paper. There are two kinds of litmus papers we use here. One is called as a blue litmus paper. Basically the litmus paper is extracted from a lichen. We will be discussing about the lichen species later. Now this blue litmus paper, when you place on any acidic, it may be organic or mineral. What is an organic acid and what is a mineral acid? We had already discussed the point. Mineral acids are the acids that are like HCl, H2SO4, HNO3. These are the acids that are present in the lab. Then what is an organic acid? The acids that we are using in our regular day-to-day life. There is the citric acid from the lemon. Even when you place the blue litmus paper on a piece of, on the cutted part of the lemon, you can observe the surface that is contacted of the blue litmus to the lemon juice, it turns into red color. So here we can observe with an indicator. This indicator is a blue litmus paper that is going to turn into red color in the presence of the acid. So this is a simple technique to find out the compound is an acid or not. What is the point? Acids turn blue litmus paper into red color. Okay, let us see the overall points that we have discussed up to now. What is the first point we have discussed? Acids are sour to taste. Yes, an acid reacts with the metals by releasing the hydrogen gas. Acids are corrosive, means they eat up the surface. And also, what do the acids do? They turn blue litmus paper to red color. These are some of the properties of acids. I don't say these are the complete whole properties. These are some of the properties of the acids. Now, let us see how we are going to classify the acids. We are majorly classifying the acids into two kinds we already discussed. That is called as an organic acid and the inorganic acid. Whatever it may be, the organic acid or inorganic acid, we can easily identify with the help of an indicator. What is the indicator here? The word meaning. When you are going on a bike or on your car, you generally give a signal whether you are taking the right side or you are taking the left side. Means you are giving an indication. That is, the behind person can understand that you are going to take a right turn or left turn. It is indicating to which direction you are moving. Here our chemical indicator is a substance that will give a change in color in the presence of the acidic medium or in the presence of an basic medium. So what is an indicator, chemical indicator here we call? See the definition once. Any substance that gives a visible sign, usually by a color change of the presence or absence of a chemical species such as acid or an alkali in solution. The bases that are soluble in water, they are called as the alkalis, children. So if you are placing a blue litmus paper into a test tube containing a solution, if it is not turned to red color, then what final conclusion you can say? It is not an acidic solution. It may be a basic solution or it may be a neutral solution. If acidic solution is there, then only the blue litmus paper will turn into red color. So that is the meaning, usually by a change in color of the presence or absence of a chemical species. Here our chemical species are the acids or bases. Other than the blue litmus paper, what else chemical indicator we can use? We can use the red litmus paper also. But the function of red litmus paper is to detect the presence of a base. Means when you dip a red litmus paper in a basic solution, then it turns to blue. So how do we detect the acid? Blue litmus paper will be turning to red. How do we detect the base? Red litmus paper will be turning to the blue. That is the indication of the litmus paper that we use here. Other than these two, blue litmus and red litmus, we are going to use two more kind of indicators. That is called, one of it is called as the methyl orange and another one is called phenolphthalein. What is another one called? Phenolphthalein. Yes, what is the methyl orange? In your upcoming classes or grades, in your plus 1 and plus 2, you will come across the titrations. In those titrations, you will be using these indicators especially. Means it will indicate whether the medium is an acidic medium or the medium is an basic medium. Let us see how this indicator will be like. You can see the bottle in the middle. I got a methyl orange bottle here. It is an indicator. I had taken two beakers. On left side and on right side I had placed them. In the left side I had taken some acidic content in it. It may be an organic acid or inorganic acid, whatever it may be. And on the right hand side I had taken some base. But I forgot to label them, that these are acidic solution and the another one is the basic solution. At this situation, I can use a small drop of them to check whether it is an acidic solution or basic solution. How? When we place a drop of methyl orange in either acidic solution or basic solution, if the solution is acidic in nature, this appears to be red in color. When the solution is appearing to be red in color, then we say it is an acidic solution. Now some of us will have a doubt, what is the basic color of methyl orange? It is having reddish orange color. What is its color? Reddish orange color. Which one? Methyl orange is an reddish orange color. But in the acidic medium, it appears completely to be a red color solution. By that we can say the solution is an acidic solution. Now let us see what is the color of the methyl orange in a basic solution. We can observe whenever we place a drop of methyl orange in a solution, and if it turns to yellow color, we confirm it is the basic substance. So other than the blue litmus paper and red litmus paper, we are using this one as the next indicator, that is called as the methyl orange, which turns to red color in the acidic medium and the so-called yellow color in the basic medium. So we had already given the definition. Chemical indicator is a substance that detects the presence or absence of a chemical species by changing in its color. So these are all color indicators. What are these? Are all color indicators. Let us take the next one that we had called phenolphthalein. So in the middle I had placed the phenolphthalein bottle. Now I didn't label two bottles that I had placed left side to it and also right side to it. But if I drop the phenolphthalein in a solution that we don't know whether it is acidic or basic. If it is acidic, the phenolphthalein remains colorless only. It may be the neutral substance also, but we cannot detect the phenolphthalein in the neutral substance or in the acidic substance because it remains, basically phenolphthalein is a colorless solution only. So in the acids, if you drop it down, it remains in the colorless only. But when it is present or it is dropped in a base, then it changes to pink color. Now what is the change in color of phenolphthalein we observe? In acids it remains colorless, and also in the bases it is going to give a pink color. Now we had learned about blue litmus, methyl orange and also phenolphthalein. Let us learn all these three together. See, we got a tabulated data, that is the color of acids and bases in various indicators. We got three columns here. One is called as an indicator column, another one is called acids and another one is called bases. In the indicator, when you use blue litmus and if at all it is dipped in an acid, what color does it turns into? It turns to the red color. Does it will have any effect in the base? No, there is not change in the blue color when it is placed in the base. So we say there is no change. Now let us see what happens when a red litmus paper is dipped in acids. There is no change in its color. But when you place the red litmus paper in a basic solution, it changes to blue color. Yes, these are the indicators, the indicator papers that were used. And also we had studied about the methyl orange. In the acids, what is the color of methyl orange? It turns to the red color. And what is the color of the methyl orange in the bases? It turns to the yellow color. What is the basic color of methyl orange? Reddish orange color. Naturally it occurs as the reddish orange color. Okay. Now let us see the next indicator, that is called as the phenolphthalein. In acids, what does it appear as? It appears as the colorless solution. But in the bases, it appears to be pink color in the solution. Very, very important tabulated data, children. Let us continue about the indicators. The indicators up to now that we had learned, these are all color indicators. But there are some indicators that helps us to detect the compound is an acid or base by observing the smell of the compound. Yes, such kind of indicators are available in and around at our home and in our surroundings. These indicators that indicates the presence of an acid or base with their smell, we are going to call them as the olfactory indicators. What do they call as the olfactory indicators? Yes. So let us give a definition for them. The indicators whose odor changes in acidic or basic medium were known as olfactory indicators. Yes, these will be changing their smell either in the acidic medium or basic medium. Some of the examples that I had said, they are present in and around us. We can take the onion. Don't let the onion to be taken directly. First it must be chopped into the small pieces and then we go on using it. Do you know the clove oil? Yeah, the cloves that are available at home, they are also used to detect the presence of an acidic or basic medium. And even the vanilla flavor that you use in ice creams or the vanilla essence that is extracted from the vanilla plant, these are also used to detect the presence of a compound, whether it is an acidic or basic. How and what is the end of the reactions we are going to study now. Let us see the activities in a very simple way. These are taken from the NCERT textbook. Let us take up the first activity. That is here on the top you can observe I had taken the onion, because what is the purpose of onion? Onion acts as an olfactory indicator. Means olfactory indicator means whose odor changes in acidic or basic medium. Their order will change in the acidic and basic medium. So it's called an olfactory indicator. Then now our task is to cut this onion and chop them into pieces. After chopping them into pieces, take 3 cloth strips. You are going to take the cloth in a thin strip type and you are going to place this cloth tied for the onion pieces. And now we are having the 3 cloths. That is, one cloth piece we are calling as a reference strip. Means we know what is the smell of the onion. So in order to keep it the same, we have taken one of the cloth piece as the reference strip. On another cloth strip, we are going to add few drops of acid. What are we going to add? The few drops of acid. On another cloth piece, we are going to add few drops of base. I have taken 2 test tubes here. In the test tube A, I have taken some compound that is an acidic compound. In test tube B, I have taken some basic compound. I am going to take a dropper. I am going to place 2 drops from that test tube A onto the second cloth strip. If at all you get the same smell of onion, it indicates the substance of the A is an acidic substance. If you place the drops from the test tube B and place them on the third cloth strip, if you don't observe the smell of onion, it shows the test tube B contains the base. Means in a short we can conclude that in acidic medium with respect to the onion, the olfactory indicator, it remains the smell of the onion. Acids will remain the smell of the onion, but the basic medium, the smell is not observed or the smell is disappeared. So if you want to observe it is a basic compound, you can just conclude if you didn't get any smell of the onion. after placing the drops of base on the cloth strip, then we can say it is a basic compound. These are the two main observations. The same observations will be continued for the remaining activities also. We will be giving the final conclusion later. So before we continue, let us conclude. Acids will retain the color of the onion, but the bases will not give the smell of the onion, or the smell disappears. Let us take the second one that we had got here. What we got here? We got a clove oil. How is a clove oil taken? Can you could see the flower here? Yeah, these flowers are then developed into the cloves that we use regularly at our home. From these cloves we are going to extract the oil that is called as the clove oil, or it is called lavang tail. What is the main purpose? If any person is having the toothache, severe toothache, you can place it in the region where the person is feeling pain, so that he will be free from the pain. So it is used to relieve toothache. Which is used to relieve toothache? Clove oil is used to relieve the toothache. Now the same practice we are doing. What is the same thing? We are going to take two test tubes labeling A and B. In the A we don't know what is the solution, but if you place the so-called the clove oil on again 3 strips of cloth. Now it is not our onion, it is our clove oil. We are going to take 3 strips of the cloth. One strip will be the reference strip, that is going to give the smell of the clove. Here the clove oil we are going to take, and next on the second strip we are placing the compound from the test tube A, and the third one we are placing the compound from the test tube B. If at all you still get the smell of the clove oil, it indicates in the test tube A we had the compound acidic medium, the smell will be retained. But if you don't get the smell of the clove oil, it indicates the compound is a basic compound. So what conclusion we can give? It acts as an olfactory indicator. Which one? The clove oil also acts as an olfactory indicator. In the acidic medium, the smell is retained, but in the basic medium, the smell is disappeared or lost. Now we are taking the third one, that is called, we call vanilla extract. Let us see here. The vanilla extract. Where do you use vanilla, children? You are well interested in having your ice creams. Yeah. These ice creams, vanilla flavor that you call, is extracted from Vanilla planifolia. The flowering we get here, but the actual plant name is called Vanilla planifolia. You can observe the bud there. It's the plant that we are going to get. It is used as flavoring agents. Means you can apply into any cakes or so-called ice creams to get the flavor. It is also going to be used as the olfactory indicator. Here, when you place the vanilla flavor on 3 pieces of cloth, like our onion, first strip we will remain as the reference one. Second strip, along with the vanilla flavor strip dipped with, we are going to add few drops of acid, and the third one we are going to add few drops of base. Then if at all the compound is acid, the smell is retained. But if the smell is not retained, if it is disappeared, we can say it is a basic compound. So whatever it may be, the so-called onions or the vanilla essence or the clove oil, in all the three, in acidic medium they retain their smell, but in the basic medium the smell is lost. So using these three, we can observe the smell in acidic medium, but does not observe the smell in the basic medium. Hence these are used as the olfactory indicator. This is what for today's session, children. And next we come across with the remaining properties of the acids. Thank you.